Sun tanning. How sunlight works. Sunlight arrives on Earth in three forms: infrared heat, visible light and ultraviolet. Ultraviolet light is classified into three categories: UV 315 to 400 nm, also known as black light, which causes tanning; UV 280 to 315 nm, which causes damage in the form of sunburn; UV 100 to 280 nm, which is filtered out by the atmosphere and never reaches us. 99% of the sun's UV radiation at sea level is UV. It is the UV that causes most of the problems related to sun exposure, things like aging, wrinkles, cancer and so on, although research is increasingly implicating UV as well. One of the interesting things about UV radiation is that it is reflected by different surfaces. These reflections can amplify the effects of UV exposure. For example, snow reflects 90% of UV light. That is why you can get snow blindness and severe sunburns from skiing on a sunny day. Sand can reflect up to 20% of UV that hits it, meaning that you can get extra UV exposure at the beach. On the other hand, certain things absorb almost all UV radiation partially or completely. Glass is one of these substances. Many glasses are very good absorbers of UV, which is why you may have heard that you cannot get sunburn in a greenhouse. Just make sure it is glass and not plastic covering the greenhouse. Most sunscreens use chemicals that have the same UV absorbing properties. So, now that we know all about the skin, we can start to actually understand tans and sunburns. When you get a tan, what is actually happening is that the melanocytes are producing melanin pigment in reaction to ultraviolet light in sunlight. Ultraviolet light stimulates melanin production. The pigment has the effect of absorbing the UV radiation in sunlight, so it protects the cells from UV damage. Melanin production takes a fair amount of time. That is why most people cannot get a tan in one day. You have to expose yourself to UV light for a short period of time to activate the melanocytes. They produce melanin over the course of hours. By repeating this process over 5 to 7 days, pigment builds up in your cells to a level that is protective. The previous paragraph applies to Caucasians. In a variety of other races, melanin production is continuous, so the skin is always pigmented to some degree. In these races, the incidence of skin cancer is much lower because cells are constantly protected from UV radiation by melanin. Melanocytes actually produce two different pigments, eumelanin brown and pheomelanin yellow and red. Redheads happen to produce more pheomelanin and less eumelanin, which is why they don't tan very well. In albinos, the chemical pathway that produces melanin cannot proceed because an enzyme called tyrosinase is missing. Therefore, albinos have no melanin in their skin, hair or irises. Melanocyte-stimulating hormone (MSH) is produced by the pituitary gland. MSH flows through the bloodstream and reaches the melanocytes, encouraging them to produce more melanin. For example, a person injected with a large dose of MSH will get darker. The pituitary gland is actually quite interesting. It is tied into the optic nerve, which means that it can sense light. If you have ever raised chickens for eggs, you know that in the winter egg production falls way off. You solve this problem by providing light in the chicken coop. The extra light stimulates the pituitary gland in chickens, which causes the gland to produce a hormone essential to egg laying. In humans, light affects the pituitary gland as well, and one result is the production of MSH. A funny side effect of all of this is that wearing sunglasses may make you more susceptible to sunburn. See this page for some thoughts on the subject. Skin damage and sunburn. If you are Caucasian and you don't have a tan, then the cells in your skin are not protected from the sun's ultraviolet radiation. You are therefore an easy target for sunburn if you spend too much time in the sun. As anyone who has a sunburn knows, sunburn leaves your skin red and extremely painful. In severe cases, the skin forms blisters. When you get sunburn, your skin is actually damaged by UV radiation and your body is responding to the damage. Here is a specific medical description of what is happening from this article. Sunburn is a popular term applied to the marked erythema and pain that commonly follows injudicious sun exposure. A sunburn is really a delayed ultraviolet B-induced erythema caused by an increase in blood flow to the affected skin that begins about 4 hours and peaks between 8 to 24 hours following exposure. The underlying cause of this vascular reaction is direct and indirect damage to specific cellular targets from photochemical reactions and the generation of reactive oxygen species. Damage to DNA, and the activation of several inflammatory pathways, particularly involving prostaglandins, are thought to trigger this reaction, ultimately leading to vasodilation and edema. Biologic response modifiers released by both keratinocytes and lymphocytes also play a role. The development of erythema therefore implies that enough ultraviolet damage has occurred that inflammatory pathways have been activated. Erythema is probably best thought of as a total failure of sun protection, and is a marker for severe UV damage. Several lines of evidence suggest a relationship between erythema and DNA damage. There is rough correlation between pyrimidine dimer yield and susceptibility to erythema with sun exposure. Wavelengths that are the most efficient at producing erythema are also the most efficient at producing pyrimidine dimers. From a scientific point of view, a sunburn can be viewed as a marker for a substantial ultraviolet overexposure that has clinical implications for skin cancer risk. It is now appreciated that there is a linkage between a history of repeated, severe sunburn and increased risk for melanoma and non-melanoma skin cancer. Translating, what this quote says is that when you get a sunburn, what you are really getting is cellular damage from ultraviolet radiation. The body responds to the damage with increased blood flow to the capillary bed of the dermis in order to bring in cells to repair the damage. The extra blood in the capillaries causes the redness. If you press on sunburned skin it will turn white and then return to red as the capillaries refill.